are starting today with Chapter 2, Section 2.1 on finding the derivative and the tangent line. We talked a little bit about the tangent line at the very beginning of the first chapter, but now what we need to do is concentrate a little bit more on exactly what does it mean when you're talking about the tangent line. So the tangent line, first of all, should be review from Algebra 2, I think maybe it was the first time you heard about what a tangent line is. A tangent line is a line that touches the graph at exactly 1 point. And if you have a crazy looking graph like this example right here, there are tons and tons and tons of tangent lines throughout this whole curve. So if we are trying to figure out something about this tangent line right here, this is just one tangent line to this graph. There's another tangent line over here at this point. There's another tangent line right here at this point. There's an infinite number of tangent lines on this curve. And what we're going to do today is concentrate on finding the slope at various tangent lines on certain curves. And that's where limits come into play. And I'm going to rest assured right now that the limit part of this is not going to be horrible. You need to have like a basic understanding of what limits mean in order to be successful with at least this part. Okay? So first of all, we need to review what slope means. What does slope mean? Okay, it means rise over run. Yes. Here's the formula: y2 minus y1 over x2 minus x1. But there's something else I don't have written in my notes, but it's really important for us to understand about what slope means. What does slope mean? The rate of change. Very good. Slope means the rate of change. Very nice. So you may even want to write that down. Slope is the rate of change. And when we are talking about the slope of tangent lines, what we are really doing, I wrote rate of tangent. Rate of change, I get for talking while I'm writing. What you're doing when you're figuring out the slope of a polynomial like this, what you're doing is figuring out the rate of change at various points along this curve. And people get paid lots and lots and lots of money, believe it or not, to figure out, to apply calculus to being able to figure out the rate of change at various points along crazy curves. Because people study patterns and curves in all kinds of things in the world. And if they want to know what is happening at this specific point, you find the slope of the tangent line, and that will give you the rate of change. So if you want to be rich someday, learn this. Okay, so in order to find the slope, you guys know that you need two points. But if you are finding the slope of a tangent line, all you have in this case is 1 point. Would you agree? Because a tangent line only touches this curve in exactly 1 point. So what we need to do is figure out another point on the tangent line in order to be able to find the slope. Well, what we want to do is find a point that is so close to that point that we have on the tangent line that change, or that the difference between the 2 points is almost non-existent. There's almost no change at all. So what we're going to do is try to figure out, we're going to find the limit as the change in those 2 points approaches what value? Approaches 0. We want there to be almost no change between the 2 points. All right, so what we're going to do to find the slope of a tangent line is we're going to use 2 points. And those 2 points that we're going to use are x, f of x. So we need to talk about what that means. You have some x value at a certain point, and the y value of that point is the value of the function when you plug x into it. Does that make sense? So in other words, this f of x is like the y. This is the x, this is the y. But we need another point. And that other point I just told you had to be really close to the first point so that there was almost no change between the 2 points at all. So the other point that we're going to use is this thing right here. We're going to take that original x value and we are going to add to it the change in x. What do we think that? What do you think that change in x is going to be? It's going to be 0. We want this change in x to almost be nothing so that we can calculate the slope of that. Remember, we need 2 points, so we're going to pick another point that's really, really close to the original point. So we're going to take x and add almost nothing to it. But when we plug in x plus almost nothing into the function rule, we're going to get a y value out of it that is going to be whatever the value of the function is when you put in that x plus almost nothing. So we call it f of the value of the function when we plug in x plus the change in x. Now I know this still looks fuzzy. It'll come to you, I promise you. The slope, remember to find the slope. Remember the formula we had written at the top of your notes? It was y2 minus y1 over x2 minus x1. Do you remember that? So here's our 2 y values right here. This is an x. This is a y. In fact, I will call this y2 and x2, this one y1, that one x1. So to figure out the slope, we are going to take the 2 y values and we're going to subtract them. So here's this y value, which is f of x plus the change in x, minus the original y value, which is f of x. And then on the bottom, we have to subtract the x values in exactly the same order. So we have x plus the change in x, and we are going to subtract from it the x value. When you clean this all up, this part doesn't change because we don't know the value of the function when we replace x with x plus the change in x. By the way, I didn't really talk about this. You guys, what does triangle mean?
Change.
It means change in. Okay, so you knew that. I figured you did, but I didn't really talk about it. All right, so the top doesn't really change. But the bottom, when you take x plus the change in x and you subtract x from it, do you see how the x's cancel out?
Mm-hmm.
So on the bottom, we have the change in x. So to figure out the slope of a tangent line, you take the 2 y values, you subtract them on top, and on the bottom, all you need to do is figure out what was the change, how much did the x value change? What is this going to be approaching, though? 0. We want there to hardly be any change in our x value at all. All right, so the change in x needs to be small, 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 small. So we have to figure out, we have to find this is where limits come into play. We want to figure out what is the value of this slope when the change in x is very, very small, as it approaches almost no change at all. So I've added this little bit right here. We're going to figure out the limit as the change in x approaches 0. This part right here does not change at all. This is the same as what we had up here. So an example of that. Now, this might seem like an awkward example because I am talking about a line. 2x minus 3, you guys know that's a line, right?
Yep.
I hope you know that's a line. So you graph the line, you get this. Well, what is the slope of a line that is tangent to this? Seems awkward because anything tangent to this, why would you be talking about a tangent line to a line? And I won't ask you to do this a lot. We're going to talk about this example just for the sake of talking about it because I feel like the math is really, really important here. But after this, the problems that we're going to do are going to be crazy curvy graphs like this, and you're going to have to figure out what is the slope of the tangent line right here? What's the slope of the tangent line right here? This one's a little awkward because it's a line already. But let's do it. Here's the function, f of x equals 2x minus 3. Find the slope of the tangent line at 2, 1. At 2, 1. So, the value of the function, remember on the top, in order to do this, we need to figure out the value of the function when you replace x with x plus the change in x. And then we have to have the original function also. So f of x plus the change of x is equal to, I go back to the original function, 2x minus 3. Go back to the original function, and you replace the x value with x plus the change in x. Are you with me? So you have the 2, you have x plus the change in x, finish your parenthesis, minus 3. And then you're going to subtract from it the original function, which is just 2x minus 3. I just rewrote it from up there. All right, so the limit as the change in x approaches 0 is equal to this thing right here. I put in right here. Minus the original function, which is 2x minus 3. And when you do this, by the way, this thing right here, the change in x, is also going to be, in fact, both of them, I replaced with 0, because what we're doing is figuring out what happens to this as the change in x approaches 0. If you plug in 0 here, and you do all the math, you're going to end up with 0 over 0. What does that mean to you? Indeterminate, you need to do algebra. All right? So, I go back to the original problem. I distribute a 2 into the parentheses. So we have 2x plus, and then 2 times the change in x. 2 times the change in x. We still have a minus 3. And then this 2, excuse me, that negative needs to be distributed into the parentheses. So we have a minus 2x and a plus 3. All over the change in x. But it just so happens that these two x's, a positive 2x and a minus 2x, they cancel out. Negative 3 and positive 3, they cancel out too. What are you left with? You are left with 2 changes in x all over the change in x. So 2 the change in x over the change in x, the 2 changes in x's cancel out. What are you left with?
2.
You're left with 2.
Well, why didn't you do the change of that? Did you already cancel them out at the bottom or something? Could you just put the change of x?
I'm not sure what you're asking me.
When you divide, just divide by the change of x.
Right here?
Yeah. Where did you get that? From the.
Where did I get this? Why did I get this change in x? That's part of the formula that you need in order to calculate the slope.
So you just already canceled out the x's.
The x's right here? I'm not sure.
I'll just ask you later.
Okay. Are you sure? All right. All right. Let's keep going. I give you another rule. F of x is equal to x squared plus 1. And what we're doing is calculating the limit as the change in x approaches 0 again. I wrote down the formula. This formula right here probably would be a good thing to start committing to memory. By the way, what kind of graph is this? Parabola. Parabolas, as you know, are not lines. In fact, this parabola is going to look like this, roughly. There are an infinite number of tangent lines that touch this parabola. So if there's an infinite number of tangent lines that touch this, we know that this graph is not a perfectly straight line, so it does not have what we call a constant slope. It's going to have a different slope everywhere on this curve. So the limit as the value, or excuse me, as the change in x approaches 0 is going to be, all right, please, please, please make sure you're hearing me out here. Here, this right here is the original function, x squared plus 1. But the x value is being replaced with x plus the change in x squared plus 1. So in other words, this is the original value, the original y value of the function. y2, I should say the second y value. Minus the first y value. Here's the first y value. We need to distribute the negative sign in. This right here is the difference in the two x values on the bottom of your slope formula. So, we need to FOIL this. X plus the change in x squared. I FOILed it right here, but I think I probably need to show you how I FOILed it over here on the side. Maybe, maybe not. X plus the change in x squared really means x plus the change in x times x plus the change in x. We need to FOIL this. So when we FOIL it, we do x times x is x squared. We do x times the change in x is x times the change in x. We do the change in x times x. In other words, we're multiplying this by this, which is x times the change in x. And then we do the change in x times the change in x, which is the change in x squared. Now, when I showed you guys how to do these things earlier in the year, what did I tell you to do? Put a y in there. I don't care, put a y in there if you want to. If it makes it easier for you, use a y. Then go back and replace the y's with change in x's after you clean it up. I know a lot of you I saw a lot of you doing it that way, which is certainly fine. This has to be cleaned up now though. This is the same thing as x squared plus, we have two of these. We have x change in x plus x change in x. How many of them do we have?
Two.
We have two of them. So it's 2x change in x. And then at the end we have plus change in x squared. It might be a good idea to memorize this. In fact, I'm thinking about maybe having you guys write all of these, because we're going to have to start cubing this thing and maybe even putting it to the fourth power. I'm considering maybe having you guys write down a little cheat sheet. So you can go right from here, x plus the change in x squared, right to here, so that you don't have to go through this process every single time. Because going through this over and over and over again, well, you just won't like that. I promise you won't like that. So it might be a good idea. We'll start a list of these things on a separate sheet of paper, and you guys can just refer back to them quickly for reference. All right, so we have x squared plus 2x, the change in x, plus the change in x squared. Don't forget the plus 1. When I do these things, I oftentimes will forget that little thing that's added at the end. Don't forget that. We have plus 1, and then we have to distribute that negative sign into the parentheses. So a negative times x squared is negative x squared, and then a negative times 1 is negative 1. Then you need to collect like terms. By the way, don't forget this either. Change in x has to go on the bottom. So we have an x squared and a minus x squared that cancel out. We have a plus 1 and a minus 1 that cancel out. You with me there?
Yep.
So what we're doing is figuring out the limit as the change in x approaches 0 of 2x, the change in x, plus the change in x squared. I wrote it down right here. Divided by the change in x. Now we need to clean it up a little bit more. I recognize that both of these terms, this term and this term, both had a change of x in common. So I factored it out. The change of x, I factored it out. And it leaves me with 2x plus the change in x. So in other words, if I factor this out of this, I'm left with 2x. And if I factor out a change in x out of this, I'm still left with one more change in x. Why did I factor a change in x out of this?
So cancel bottom.
So I could try to cancel it out with bottom. The whole goal of doing that. So I cancel them out. All I'm left with then is the limit as the change in x approaches 0 of 2x plus the change in x. Well, remember, we are trying to figure out the limit as the change in x approaches 0. So that means I plug a 0 in for this. What are you left with? You're left with 2x. This isn't horrible, is it? Lots and lots of little teeny algebra steps. What is this thing called, by the way? 2x. What's that called? It's the slope. And I have always told you, and all of your math teachers have probably always told you, that the slope is a number. This is not just a number. This is a polynomial, 2x. So that means that you need to use this rule to calculate the slope. So if I said to you, okay, well, what is the slope at an x value of, say, 5? What would you do? The x value is 5. What would you do to this? You'd multiply it by 5. So you'd get 10. The slope at that value of 2 would be 10. So you're going to use this rule to calculate the slope. Okay. So that's the slope. Then the next thing I talked about was this. Well, what is the slope? And I didn't even know that this happened. What is the slope at 2, 5? Well, this is the rule we're going to use. We're going to use 2x. So I took this x value and I put it in. Replace x with it. 2 times 2 is 4. What about your slope at negative 3, 10? We don't really care about the y value. What we really care about is the x value. So you take that negative 3, you plug it into your rule, into your 2x, you get negative 6. What about at 526? Put in your 5. You get 10, okay? All right. right now, what I would like you to do is get out another sheet of paper. Not part of your notes, part of your notes, but a separate part of your notes. Please get out your notes, and I want you to write down, this is a good place to write it down. What I would like you to write down is this. I want you to write down that x plus the change in x squared is equal to, this is what it's equal to right here. We already did the math. I showed you all the steps. I deleted it already, but it's right here. Please write this down on your separate sheet of paper. This will be helpful. It's x squared plus 2x change in x plus the change in x squared. Write that down, please. That will be very, very helpful. You'll be glad you have it. So whenever you have to square x plus the change in x, you don't have to do all the math. You can just go right to this and write it down. It'll save you lots of steps, lots of work, lots of time. Can I go on? Yep, you have this written on your notes. You guys can look back. Okay. I'm asking you to write that because hopefully you notice in the next problem, what do you need to do?
Change cube.
You need to cube it, and then it gets ugly. It gets really, really ugly. So, in fact, before I even start this problem, we're going to go through the math to come up with this horrible, horrible product. Let me see. Alright, this is what we're going to do. X plus the change in x, we're going to cube it. So, when you take x plus the change in x and you cube it, that really means x plus the change in x times x plus the change in x times x plus the change in x. Horrible. But, just a second ago I had you guys write down what was the product if we just multiplied these two. If we multiplied the first two. So if I can have someone read that to me.
X squared.
Okay, x squared plus
2x, a change of x.
2x change in x.
Plus change of x squared.
Change in x squared. Alright, so we already have the first two done. You with me there? All we need to do now is take that product and multiply it by this thing. So we have to multiply that by x plus the change in x. So that means that we need to take this x plus the change in x and we need to multiply it to each of the three terms in the first one. So we're going to go x times x squared, x cubed. Keep me on my toes here because it's really easy to lose track of what you've already multiplied. X times 2x change in x. Well, that means 2x squared times the change in x. You okay with that? So x times 2x is 2x squared plus we still have that change of x there. And then we need to multiply x times the change in x squared. That does not mean it becomes x cubed. It is going to stay x change in x squared. Done with the x. Now we need to move on to the change in x. So we're going to do the change in x times x squared. Well, that is the same thing as, I'm going to do x squared first times the change in x. And then we have the change in x times 2x the change in x. That's going to get me 2x change in x squared. Still with me? And then we have the change in x times the change in x squared. That gets me the change in x cubed. And now we need to collect like terms. If there are any, maybe there aren't any. Are there any like terms? There are like terms, yes. So we have an x cubed. Is there anything else in here that's just x cubed? Anything else that's just x cubed?
No.
No. So I'm going to leave that just as is, x cubed. All right, we have 2x squared change in x. is there another x squared change in x?
Yeah.
There is. It's right here. So I have two of them here, and I have another one here giving me a total of three of them. So we have three x squareds change in x. Now I have x change in x squared. Are there any other x change in x squareds? There is. There's 2x change in x squared. So if I have one of them here and two of them here, how many do I have total? You have three of them. So I have plus 3x change in x squared plus the change in x cubed. Put a big old box around this because now you don't have to do it again. So if you're mumbling and grumbling about having to go through that, the hard part's over because now you can just use that as reference, okay? So whenever you have to cube an x and x plus change in x, just go to that paper. Write it down. Don't redo it because that's a pain in the butt. I agree. There it is. Do you have it? Can I erase?
No. Wait.
Oh. You're not to erase.
Didn't you say before we could put in y? That's confusing.
Didn't I say before that you could what?
Put in y and then at the end.
Yeah. But now, well, I guess even now it might still be helpful to use a y. Yeah. You could still do that, yes. Yes.
So when you do the 2x change in x times the change in x, where is 2x?
Okay, hold on. Where are you talking about?
The third one,
The 1, 2, third step?
Oh.
then the x change in x squared.
Change in x squared, yeah.
Isn't it 2x change in x squared?
Well, this one is just x change in x squared. This one is 2x change in x squared. Total giving you 3 x's change in x squareds. That's like having 1x plus 2 x's. That would give you 3 x's, which is just more complicated because there's more than just an x. I'm just going to do that. All right. So, in this problem, we have x cubed minus 2. So we write the equation of the tangent line. To do that, you take the limit as the change in x approaches 0. So I go back to my original rule. Here we go. X cubed minus 2. So I take this x value right here, and I replace it with x plus the change in x. And I have to cube it. And then I have to subtract 2. But then I have to subtract from it the original rule, which is x cubed minus 2. And then I have to divide that by the change in x. Alright, so x plus the change in x cubed, we just did it. And where does it end? Right here. It ends right there. That's x plus the change in x cubed. We have to subtract 2 from it. So I minus 2. And then I have to subtract x cubed minus 2, which means I have to distribute the negative in, giving me minus x cubed and a plus 2, divided by the change in x. I start looking for things that are similar. I have an x cubed and a minus x cubed. They cancel out. I have a minus 2 and a plus 2. They cancel out. I'm left with 3x squared change in x plus 3x change in x squared plus the change in x cubed. Just the leftovers. That goes right here. Divided by the change in x. I have a change in x on the bottom. What does that mean?
Take a change.
Probably want to take one out. Try to find it, decide if you can take one out. And you can. They all have a change in x in common. So they cancel out. So the change in x, they cancel out, leaving you with 3x squared plus 3x, the change in x plus the change in x squared. if we're trying to figure out what happens as it approaches 0, that means I need to replace this with 0, need to replace this with 0, leaving you with 3x squared. That's your slope. This is the function that you are going to use to calculate your slope.
What happened to
So
the
if, I'm sorry, what did you say?
We do not need the 3x.
This 3x squared is all I ended up with, because this change in x gets replaced with, I should say, this change in x gets replaced with 0. This change in x, this is the change in x squared, which means the change in x times the change in x, that means 0. Those are like gone, because you're replacing them with 0. All you're left with is whatever didn't have 0 next to it, which is 3x squared. So this is the formula, or the equation, or the function rule that you're going to use to calculate your slope. So what is your slope at 2, 6, at the point 2, 6? Well, you use this rule, and you replace your x with the x value, which is 2, 6. So I put my 2 in here, so I get 3 times 2 squared. 3 times 2 squared is 12. So we use, okay, now, and this is new. This is not new, but you haven't seen this in a long time. Use this formula, y equals mx plus b. We are talking about the point 2, 6. By the way, let me go back to the directions for this problem. You aren't supposed to just calculate the slope for this problem. You are supposed to write the equation of the entire tangent line, not just calculate the slope. So you go back to this formula, which you used probably in middle school, and then when you were in 9th grade, and 10th grade, and 11th grade. I know it's come up periodically throughout many, many years. The y value is 6, so I put a 6 in here. The slope is 12, so I replace the m with the 12. The x value is 2 plus b. So we have 6 is equal to 12 times 2, which is 24, plus b. You do the math. You figure out that the b value is negative 18, so the equation of the tangent line is y equals 12x minus 18. How do you feel about math today?